Good morning. How's everyone? How's your studying been going? I said I would spend some time answering your questions about the exercises I gave you so far that will be examine material for your test tomorrow. Does anybody have precise questions? Someone sent me questions, but they're not sure which document. I'm just trying to find the document they're referring to. The first review, maybe it was. 3.6. So I'm not sure how the students are studying, but I make these videos in the hopes that you will review them. Okay, so when I see that there's only been 50 or 40 views on a video, I imagine that you are not studying them, because you should be watching them several times, unless you're downloading them, or unless you really understand them. But if you're having trouble, you should review these videos. They're your best resource, these videos with the notes. Obviously, everything I give you is a great resource. The textbook is meant for reference, and it's always good to have a reference text. You can read the background, and also I did expect you to solve some exercises for assignments. But in terms of the test, you can expect questions like these, so it's really important that you understand the answers. That it's very important that you not look at the answers and try and solve them without knowing the answer initially. Sorry. So that you can motivate, the thinking process, and maybe take notes. Make notes in red and highlighter on your solutions. You should print the solutions. I say you should print all these documents. That's a suggested study tool. I'll print them all so you have them in front of you. Some people like to work electronically. When it comes to mathematics, I like everything in front of me. And maybe some of you would work better if you did. So, having said all of that, you're going to have to carve some time out tomorrow to write the test. Like I said last time, it's an hour and a half. It's meant to be completed in an hour and a half. I'll give you some questions to choose from. You should be working independently with all the resources that you've been given. You can go on the internet, you can do all kinds of things, but you cannot speak or communicate with another student or another human being. Okay, it's supposed to be independent work. And your resourcefulness in solving the problems is what I'm testing, not your memory, obviously, because you have access to everything. But in the meantime, you should work on your memory. You should make study cards. You should take those summary sheets that I prepared for you and keep them together, put them in with a plastic cover, and study from those. Those are your outlines for studying, so that in the future, if you do go on and you do want to write a CFA exam or another professional exam, you have all those ready for you to pick up, and they'll trigger memory for you. And you'll be able to, like muscle memory, if you've ever heard of it, it's in you, and you just need to tap it or trigger it, and it'll all come back to you. Okay? So let's see. I think it's 3.6. that I was asked about. Oh, I need the PDF. It's not gonna show up. Wait a second. I need to make the PDF. 1 minute. You can write your questions in the chat, what you'd like me to look at. Otherwise, what I have intended for today is a review of statistics, because that's going to be the foundation for what we do next. Statistics will be our tool. Okay. So are there any questions on this document that students would like help with? Yes, the time frame will be the same. It'll be, I'll post at 9 a.m. and you'll have until 3 p.m. But my comment was to say that you should allot a minimum of 1.5 hours, as much as, you could work on it for 6 hours if you like. I'm not stopping you, okay? But you have to send it to me before 3 p.m. Calvin is asking about whether he has to write something. This is a quantitative course. We might have to write something like these problems here that I'm displaying, but mostly it's going to be calculations and solutions, solving problems. If you want to use Excel, Ariette, for the whole solution of your capital budgeting, I'm fine with that, but the only thing is, it's going to be hard if you make a mistake in those tables for me to see what you did. So if you know how to display your formulas in Excel, or I'm not sure, I don't know how you're going to do it, but I need to see your formulas and how you make calculations. So in case your calculations are wrong, I can give you part marks. Otherwise, you could get 0 on the case. Well, I could give you points for just layout that you've solved the 3 parts: the income, the present value of income, present value of some investments, and present value of the tax shield, and you'd added them together, and so I could give you some points out of 10. But if you make mistakes, I won't be able to see them. I won't be able to see what you did wrong. So you could use Excel. I would do both. I would write things out and then use Excel to make it, look good. So if you have the formula at the top of your depreciation calculations table, so you've put the formula at the top, I'll know what you did. So make sure you indicate the formula somehow. Oh, Calvin, Yeah, there might be some word problems. Do you need more time for the exercise today? If you need more time, I can give you more time. I don't mind. I can make it due on Monday. I think it is due on Monday. Isn't it due on Monday? I made it due today. Trying to think. I don't mind if the quiz is extended. So I can give you till Monday. Yes, Ivana, you can send me the spreadsheet and write the formulas and exam, but it has to be neat and tidy. I like, it cannot be searching. You know, the TA cannot be searching for your answers. If he doesn't find it all clearly laid out, you know, he doesn't have to search for you. If anyone has a conflict with the test, I don't see how I can help you, because you've known about this test for from August, September, October, like, well, 2.5 months. You knew this test date. So if you have problems with writing the test tomorrow, I really don't know what to say. But if you have other obligations, and as I mentioned, the test should only take you an hour and a half. If you have other things you have to do and it compromises your time, that's fine, because it only should take you an hour and a half to do the test, okay? So you shouldn't be too worried. Unless you have a vacation plan tomorrow, that's something else. That's another issue. But you should be able to carve out, separate an hour and a half for tomorrow. Okay, so the quiz, I will extend it till Monday. Does anybody need more time than Monday? Please let me know. If you want to text me privately, you guys can text me on my phone. Okay? So, I was asked to look at these problems. I have my TA working to put the timestamps on the videos. I have 3 courses I'm delivering right now, so he hasn't gotten around to putting the timestamps for the finance classes yet. But hopefully he'll do that regularly in the future. Oh, this doesn't look like the solutions, does it? Where did my solutions go? Is this the document I shared with you? Oh, did I not give you the solution to number 5? Got erased. Well, that's fun. Let's do that then. Let's do exercise 5 together. This is document 3.6. This is a solution set. It's the solutions for 3.5. So how was this? This is the result here, but I don't have the NPV profile. Okay. So for this problem, right, what do? You generate the NPV profile. These are the cash flows. There's a 1 sign change and 2 sign changes. Since there's 2 sign changes, there's up to 2 IRRs. So what you need to do is look for them. You can depict the NPV profile with NPV on the y-axis and the discount rate on the R, and then what you're doing, so if you actually got a question like this, you'd have to show me the formula and then you make a table no, that's not the table. You make a table with the discount rate and the NPV, or you can write it with the percentage discount rate and the NPV. Set it up on your calculator, so put in these values, -100, 250, and -300. So clear work. No, I want to go to CF, second clear work. So it was -100, enter down, 250, enter down, only one of them, and then 300 negative, enter down, and then you ask for IRR compute. Oops. Aha, it doesn't work, does it? What happened? So it doesn't work. So it doesn't work, right? So that can happen. It doesn't solve for the IRR, so you have to find it yourself. Or you try to find it. In fact, there is none. Okay, so the error doesn't mean that you entered anything wrong. It's just showing you that there is no IRR. Okay, so there is no IRR, so that's what it's telling you. So what you still have to do, yes, you have to draw it. If I ask you to draw it, you should draw it. Use a graph, you see, with NPV on the vertical axis and R on the horizontal to plot the 31 points. Increments of 10 to calculate 31 NPVs. So you could go between from the negative values. I don't know why I have 31, but okay, let's see. You could start at -20, -10, 0, 10, 20, 30, 40. Oh, see, they went into the hundreds. So let's do that. Let's do that. Sorry. So that's why it's not written here, just because it's very messy looking. So if I just started at, yeah, let's do -10, 0, 10, 20, 30, 40, 50. So they're saying to go all the way to 100, 200, 300. Try all these discount rates to prove that there is none. So once you know, because there's two sign changes, it means that it could, it could have potentially crossed, and that's why there's up to two IRRs. But in this case, it didn't happen. So all you have to do is look until the values go up and then down in the NPV to know that it's not going to cross over, okay? So what you do with the CF keys that I gave you is just keep changing. Keep changing. So everything is in here. The -100, the 250, and the 300. And we're going to calculate NPV with it by picking different interest rates. So I'm going to hit NPV and tell it use 10 negative. And I'm going to enter that as the interest rate and then compute NPV. So it's -192. So now let's try the next one. So let's see if you guys can follow along. So the next one, let's put 0 in. So I'm going to put in, I want NPV, but I want to change the interest rate. So I'll put 0, enter, down, and ask to compute the new NPV. So now it's -150, so it's a little bit higher. Well, no, sorry. Yes, a little bit higher in negatives. Going towards 0. And then I put 10 in. I keep on doing the wrong thing. So I hit now NPV. I have to put in the new interest rate and then ask to compute the new NPV, and it's getting closer to 0, right? Let's try again. Let's try changing that to 20. Enter down, and let's compute the new NPV. Okay, it's still closer to 0, so it's going to be going closer and closer to 0. Let's try a higher number. Let's try 90. Sorry, NPV 90. Enter down, compute. So it's still not hitting 0. It's -51. It's not crossing. But what's going to happen if I pick 100? Enter down, it's -50. If I pick 200, enter down, compute, which is flattened out, 300, enter down. Oops, oh, I'm getting some other things. Hold on. NPV 200, enter down, compute. So it just flattened at -50. 300. So this is, I'm using huge discount rates. Enter down, compute, and now it's going down. So it flattens out and then it starts going down. So this picture, although it's a sketch, it's trying to demonstrate that it flattens out and then it starts to go down. It never crosses to make NPV positive. NPV is always negative. So the conclusion is this is always a loser. NPV is always, no matter what discount rate you use. So it means that it's not a profitable project. Well, my instructions were here. So just start at 0. That's how you know where to start. So when making the graph, it's just a sketch, it does not, well, some people will really want to do this nicely. They might want to do it in Excel, if you know how to do it in Excel. But even on paper, it's just a sketch. Really what I want to see is the pattern. I'm really interested in the pattern. So you see I didn't even put all the dollar signs here. I just kind of plotted that it's going up. Entering these as guidelines that this flattens out at -50. It's really important. I'm looking at your questions. So, how many of you understood this problem without me explaining it just now? How many of you understood it? that you actually did it yourself and you understood it. How many? Okay, used Excel. Von Marie is asking if I'm going to limit how many. Yeah, that's a good guideline, right? Is to limit so you don't, so you know you've done enough to see the pattern. This one really needed to tell you something because you wouldn't have been sure. But the idea is it's with 2 sign changes, it'll go up and down. The question is, well, whether it'll go up enough to make NPV a positive. So once it started going down, you knew that it was, was never going to cross. The reason to tell you that you need to do 31 is because I've never asked you to do that before. That's a lot to enter. So it was just to encourage you to find the solution. But if I don't tell you how many to put, I don't expect you to do 30, okay? So if I don't tell you how many to put, you can put 10. I'll try, yeah, probably 10 will be enough to see a pattern. I'll try not to make, I'll try and be as clear as possible in the questions. So some of you understood. No, Edwin understood. Kelvin. Okay, so a few of you understood. Now that I've explained it, does anybody have any more questions about this? Someone asked me to do 7 in this problem set. Can I go to 7? Okay. How did you do with this one? This is a firm considering prospective capital budgeting projects. Select the data on the projects follow. You have project A, project B minus A, project C, and project D. Consider only projects A and B by examining the incremental project cash flows B minus A. They are mutually exclusive opportunities. If IRR B minus A is 12% and the discount rate is 15%, then what is your decision? So what you're supposed to do is notice this is a positive. What does that tell you when that's a positive? You treat it like it's a finance project. So that means the analysis that follows is to use, you use your discount rate as the maximum rate of borrowing. Like you're going to compare the rate of borrowing that you got for the project, like the return, the rate of borrowing expressed by the internal rate of return is 12%. The maximum that you can have is 15 for the project to be acceptable, which means that you can invest in the project. So you should invest in B. So that's all you need is the sign. You see, I didn't even put the numbers because that doesn't matter. So you accept, so what it means precisely is that because they're mutually exclusive, you can only pick one. The one you choose is B. B is better than A. Okay, now part B was the one that the student asked me to look at. Ignoring the information in question A, assume instead that projects A and C are independent. Okay, so A and C are independent now. So that means you can pick either of them, or one or both of them, or none of them. So hard choice is subject to capital rationing. That is, it may not be able to afford both projects, and the relevant discount rate is 10%. What is the IRR of project A and C? So then we make the calculation. A is this and C is this, and they're both investment projects. So the point of the question is, to see if you know how to choose between them. Looking at the cash flows, is there an issue? Is there a conflict? Remember I mentioned the problem of scale and the problem of timing of cash flows. Brian, I'll get you your question in a second. So this one looks like it has a large initial investment, double of that, but then the cash flows are about the same. So this is not, I mean, they are comparable projects. In terms of timing, I'm trying to think, because this one is, it's a much larger investment. So this one will favor to be able to return, to pay back that investment. You want these cash flows to be retained. You don't want a high discount rate. It turns out I ask you just to get the IRRs. I don't ask you for a decision here, okay? So you just get the IRRs. And remember, this one, to get 0, it's a low discount rate. To break even, right? You don't want to discount these very high, in other words. But this one, it doesn't matter so much as it does over here. The discount rate is 41%. Wow. Okay, so that's all I've asked you to do. Then the next part is to actually think about it. How would you rank A compared to C? And it looks like, because they're both investment projects, I should pick the one with the higher IRR, which is this one. So I pick project C. It's a higher return project. And really, when you look back at the cash flows, you anticipate that because, you have this huge investment, but these cash flows are almost the same as those. So it looks like C's gonna, C is the better project. It's a better return on the investment. And that's what the numbers reflect. Does that make sense? So there's no real timing issues here. The real issue was that one project was a higher investment for about the same returns as the other project. Okay, let me answer But Marie's question for the test, can we put IRR 0? Yes, you can write it like that. Yeah, just like I did here. Okay, because don't write IRR equals. That's a mistake, and I will tell the grader to deduct marks if you write IRR equals. That's not what, that doesn't equal. Right? It's 0 equals. It's when the NPV is break even 0. Okay, so Brian's question. I had a question on how to calculate the second IRR when the NPV is also 0. How do we know which discount rates to use? Brian, are you talking about the problem before, like the NPV profile? For the NPV profile, you just follow the directions. And if there's no directions, ask me, okay? If you're really stuck to know which ones to put in, which discount rates to use. Oh, C. Okay, let me keep going. C. Consider the following statements and circle the Roman numeral corresponding to the one that is true. The NPV of Project D will be much more sensitive to changes in the discount rate than the NPV of Project A. So let's see. NPV of Project D is much more sensitive than the NPV of Project A. So when does that happen? So remember that this is all about, this is asking you to go back in your notes and look at the problems of timing and scale in the notes, okay? So when you have a difference in the set of cash flows, either it's one is a high budget problem and the other one is a low budget problem, or high budget cash flows, just much more money is spent and returned versus a low budget set of cash flows. Those are hard. The IRR will not give you the right answer for that. Okay, and when you're comparing two sets of cash flows where the timing is very different, both of these create a problem of this crossover rate. Sometimes Project A is going to give a higher NPV than Project B, and then other times with a higher discount rate, it might flip. If you remember all that, that drawing that I gave you. So is that a problem here? Do you have a timing or a scale problem between A and D? They're about the same, right? I mean, these are a little bit, no, I don't know, they're about the same, really. They're not dramatically different. They're about the same investment, not like A and C, right? These are about the same investment and these are about the same returns. So that's not going to be an issue. So there's not a sensitivity to the discount rate, in other words, because of timing and scale problems. So no, that's not true. If projects C and D are mutually exclusive, incremental analysis indicates that one should reject C and accept D. So let's look at C and D if we had to pick one. I guess you have to just check. You have to check. If projects C and D are mutually exclusive, incremental analysis indicates that one should reject. So they're saying accept D. So let's subtract them as D minus C, just because that will tell us to accept the project if NPV is positive. So take D minus C. That will make that minus 200. This will make this 40. That will be 30, 20, 10, and 0. And plug them into your calculator and find the IRR of D minus C. What do you get? Or even calculate the NPV. Actually, no, did I give you a discount rate? No, I didn't give you a discount. So just get an IRR. Did I give you a discount rate? Okay, the discount rate I used here was 15%. And B, I used a 10%. Do we have a discount rate? No. Okay, let's just do it and see what we get. So if I enter that, for 5 years, I'm just doing it on my calculator. So if you do that, what is your IRR? What do you get as the IRR? So I'll just do it on the, let me do it here. So we're going to hit CF, second clear work, and then start with 200 negative, enter down, 40, enter down, down, 30, enter down, down, 20, enter down, down, 10, enter down, down, and 0, enter down, down. And then ask for IRR and compute. So what does that tell you? And what does that mean? What does it mean? Is it likely? So that's telling you that it's an investment project. The rate of return on the project is minus 27. You should be comparing that to a discount rate. So let me just make some notes. IRR D minus C is equals minus 27%. So what does it mean? You should take that and compare it to the discount rate. We don't have one to compare it to, but is it likely that negative 27 would be greater than any discount rate that we had? No, right? Because no one uses a discount rate less than 0. So that's not true. You're not going to pick D over C. Is that better, Ariet? So that's out. Question 3, solution 3. It is possible for projects A and D to have the same NPV. Let's see. Okay, first of all, did you understand number 2? Okay. And so you might have all the elements, but you don't know how to conclude, and that's possible. Just if that happens in the test situation, just write everything down. If you don't have a conclusion, you know, I can still give you some part marks. So let's say if it was 5 points, I could give you 3.5 points, which is a lot of points. Okay, let's see. What did I say? A and D. Is it possible for it is possible for A and D to have the same NPV. How would you think about this one? Again, I haven't given you a discount rate. So if you imagine the NPV profile of A and D on the same graph, Could they cross each other? That's kind of what it's saying. So if I could, okay, look at A and look at D. They are very similar. They're very similar. Is there a discount rate for A and a discount rate for D? They don't have to be the same one. Is there a discount rate for which NPVs could be the same? The question is not very clear, is it? But that's what it's asking. So they would have different discount rates, but they could have the same NPV for different discount rates. And similar ones. I mean, they're not, those cash flows are not too different. So, yeah. That's not very clear. I agree. It's confusing. But hopefully I don't give you confusing questions tomorrow, right? But it did make you think. No, Von Marie is 1 and 2 are not true. Just 3. Right. Yeah, I see what you're saying. Yeah, that's not true either. Okay? All right, so you might not feel so, you know, the thing is, I give you quantitative problems and usually there's a final answer, but sometimes you have to think, and these are the thinking problems, which is good for you. It helps you understand better the limits of what you're doing, your assumptions, and because you have all your materials, I can ask you questions more challenging like this, or I'm not gonna say challenging, they're just different type of question. They are challenging because they're asking you to think, not to just repeat calculations. Okay, let's see. So that's that. I don't know if you want me to do any more on here. Do you have any other questions you want me to look at? Did you find any issues with my solutions to the cases? So if you have no other comments, let's take a 5-minute break and I'm going to send you the overview for the review and statistics. If you have some questions, you can write them in the chat. I spelled that wrong. Okay, I just sent you the documents. Let's see if you have questions. PI formula, page 18 in 3.1. Page 18. Oh. You want me to get the slides, right? Oh, that's not what I want. Okay, page 18. Okay, so question, Calvin, tell me. All right, so what we're doing here with the PI, if people remember, oh, it's up here. So with the PI, different from where the NPV was about dollars and you were looking at the the benefit minus the cost. I spelled benefit wrong. And percentage where you're looking at, I guess I can't compare it that way. But okay, let's compare it to the NPV. The NPV is like benefit minus the cost, right? The initial cost, to be precise. This is the initial cost, and then you use the present value of future cash flows and offset it by the cost. Adding them together, right? What the PI does is it takes the benefit divided by the cost, and it doesn't worry about the sign. So basically that's what's the difference. So when you do this, you're using benefit divided by cost. Doesn't matter that it's a negative, right? And we're always talking about investments. So it's always a positive. Is that all right? So the benefit is the present value of future cash flows and the cost is the initial investment. So you take benefit divided by cost. As opposed to the NPV, where you take benefit and you subtract the cost. So it's just a different way of using those two amounts. It's a different way of offsetting cost. Okay, one is to add the benefit and one is to put the cost on the bottom of the benefit and see if it was greater than 1. It should exceed the cost. The benefit should exceed the cost. Is that okay, Kelvin? What was any other questions? No other questions? Yes, Kelvin, it will always be positive. It said here at the top, did I say it at the top? Or did I not say it at the top? Where did I say it? I didn't say it. Maybe that's why you're confused. Hold on. Did I say it down here? Oh, okay, I said it here. You see? So it's, you would do this. If it was a financing project, I guess you would take the absolute values of the future cash flows. But anyway, we're not going to do that. You don't have to worry about that. But that's how you would, the point of this, the point of the profitability index is to have benefit on the top and cost on the bottom. So all the positives are up here, you know, and the negatives down here. And you don't care about the sign. Yeah. It's here. It's tricky. So it's a different symbol, CO. So the benefit is the present value of future cash flows. To calculate it, if you have the NPV, you just add back the initial investment. Or you just take the future cash flows and you calculate the NPV of them without the CO, without the initial cash flow. Okay. All right, so I sent you my statistics review. Statistics should be relatively fresh in your mind. Some of you might even be taking it right now. You take 2 courses in MECU, but maybe some of you have had courses other places. I really want to focus on what you need for this course, so that's why I review it and make it so we're all on the same page, level the playing field, so to speak. Okay, so we're going to start here. So I'm going to speak more in general, and then I'll get specific by the end, talking about financial data. 1 second, please. All right. Why? Okay, 2 questions for you. Why do we use statistics, and what is a statistic? Why do we use statistics, and what is a statistic? Can anybody tell me any of the answers? Either of the answers? Why do we study statistics? What is a statistic? And I don't want an example, I want a statement. No, Rafael, won't be on the test tomorrow, but I'm going to give you exercises to work on this week on this material, so. And this will be our new topic. I'm on to the new material. I'm not going to review anything else because I gave you everything, and if you don't have questions, I don't really think it's worthwhile for me to just read through solutions. But if you think that's what you want me to do, you have to ask me to do it. Okay. So Bonmari has touched the topics. Anybody else? Why do we study statistics? Or why do we look to statistics, and what is a statistic? guys are kind of dancing around the issue, but not striking the issue. You know, I heard a really interesting quote yesterday. Well, I heard someone speaking, and they made a really interesting statement about knowing. That we are conscious beings, but we don't know, right? We don't know. And the obsession with knowing and trying to know is really what statistics helps alleviate. Right? The statistics is intended to help us alleviate uncertainty, to make predictions like von Meide mentioned. We want to make prediction for the purpose of alleviating uncertainty. That anxiety or stress or anxiousness about not knowing is what we are trying to mitigate. We're trying to manage with statistics. So as boring as it might seem to some, or as tedious to others, or difficult to other people, it's worthwhile, in my opinion. My first degree is in statistics. And as you can see, we live by the virtue of statistics. I mean, decisions are made, policies are written up, they're drawn up based on statistics. So what is a statistic? What is a statistic? So the most basic definition I have for you is a statistic is a number computed from the values observed in a sample. That is a statistic, okay? So you can go further. What is a sample? A sample is it's a collection of observations taken from a population. Now, population is not just a larger data set. Population represents all the possible information available to you. So if you want to know something about GPA, for instance, of students in third year at the University of Puerto Rico in Faculty of Business, you could get all that information on the third year students and calculate their GPA, or rather than having the whole entire set, the population, you can collect a sample. And a sample is a part of the whole, and it could be representative if it was selected in a representative way, or it could just be, a bad sample and not giving us a really good prediction of the whole. So the goal of statistics is trying to alleviate uncertainty about what you can expect, using a sample to make estimates or anticipate what's happening for the greater population. You can be looking at various characteristics. You can look at, grade outcomes. You can look at sales figures. You can look at health outcomes. In case of COVID that everybody's watching, these numbers flow on our screens. We would look at hospitalization expectations, case expectations, testing rates. All these numbers become very, all these numbers are really, these statistics, and, the way they're computed, the way that the data is collected, all those levels of analysis are critical to us because they affect our life directly. Okay, now there's, some people talk about, for instance, the stock market, right? They say, oh, well, I don't have stocks. What does that affect me? What does the stock market affect me? Well, maybe you don't have a pension, but one day you will have a pension, or your parents have a pension. Pensions are funds invested in the stock market. So that does affect you indirectly. Okay. So we are going to use the properties, the science, or the rules of statistics, the theory of statistics, to try and understand financial data for making financial decisions in terms of holding portfolios. Some of you, I don't know if you've taken the course already in investments, or I think you need this course to take investments. So you will learn the tools in this part of our course to do those sorts of things, okay? To look at financial data and make decisions about financial data based on what you expect. Okay, so statistics are important. The goal of statistics is to gain information from data about a variable so that we can better understand what to expect and to alleviate uncertainty in the process. Any characteristic of a person or a thing that can be expressed as a number is called a variable. So I say, dollar sales, quantity demanded, interest rates, returns on investment. The value of a variable is the actual number that describes the person or the thing. So percentages, the actual number. If you're looking at a variable and the values of the variable don't involve a number, you can create a number. So if it's like a categorical variable, like just in general, let's talk about weight. Okay, so weight can be divided into classes. You can look at different measures, circumference of a waist. You can look at BMI. These are measures of people's weight. You can look at BMI's height and weight together in a measure. And you can divide it into categories. So you can have different classes, class 1, class 2, class 3, class 4. So you can use numbers that way, right? Group 1, 2, and 3, and 4. In finance, what we're really interested in are quantitative variables. However, sometimes they can be continuous and sometimes discrete. So continuous variables would be, dollar sales. You can have fractions, right? Dollars and cents. Quantity demanded can be in fractions as well. If you're talking about commodities like oil can be purchased by barrel or by fraction of a barrel. So that can be continuous. Discrete are things you can't divide up. Discrete variables. And there's statistics related to that too. But we mostly focus on continuous data and continuous variables. Okay, but in statistics, if you take statistics or other classes, you'll also learn how to analyze discrete data. So GPA, for instance, is continuous as well. You can have fractions. But when you have discrete data, what would be a discrete data would be something like, discrete data would be, for an example, cases of COVID, let's say. That would be discrete. And analyzing that, similar, it's a quantitative variable and similar to continuous data, but sorry, I just saw that you wrote a lot of stuff. I didn't see your questions yet. I'll look at that in a minute. So discrete data is discrete. You just have to be, it's different from continuous in analysis. You have to just be cautious that you don't violate any assumptions in doing so. Okay, but we're not going to talk about that too much. The other kind of variables are categorical variables. Categorical variables. Categorical variables, for instance, gender is categorical. Male, female, or other, or not stated. That's not a quantitative variable, okay? It's a variable still, and there's statistics that can be used to summarize that data, but it's not the same as statistics used, methods used for quantitative variables. All right, so I'm just mentioning that, but mostly we're going to focus on continuous. Okay, so what was I saying here? So a value of a variable is the actual number that describes the person or the thing. The distribution of a variable tells us what values it takes and how often it takes these values. We're going to talk about distributions in a second. So usually when we get data, we organize it and we present it graphically. Depending on the graphical representation, we pursue making calculations. We use a sample instead of pursuing the population because it could be very expensive to try and measure everybody, and it probably wouldn't be exact. Everyone or everything would be hard to do in a feasible, within a budget constraint, okay? So that's why we use samples. Okay, let me look at the questions and then I'll get into this stuff here. Thank you. Yeah, so for investments, you just have 3106, right? Okay. Right. So Martinez, about the pensions. So this is an interest to you to study pensions or insurance, right? The idea is that these funds have a reserve. So when it comes to guaranteed pensions, they're guaranteed in that a large fraction is invested in secured, low return, but more secure investment opportunities. So they'll be invested in bonds, for instance, in government bonds, particularly because those are backed by the government. And but there could be a portion of pension. It depends what pensions you're talking about. 401ks are invested in the stock market, and the degree to which they're invested can be selected by the person, how much risk they want to take on. But it just means that a part of the fund is invested securely, and another part is more invested in more risky assets. Okay, so that's it. So it depends what kind of pension you're talking about or what kind of pension you have, but pensions as a group are invested in the stock market. Okay, comments. Okay, so what we do first is we make a graphical representation of the distribution, and then based on the features of the distribution, determine what statistics to compute. So the intention of statistics, so putting it all together, a statistic is a number computed from a sample intended to estimate a parameter. Okay, so the goal is to tie it back. What we're trying to do is estimate what the actual, if we had all the data, what we would have gotten. Okay, And again, the degree to which our estimates are accurate depends on the quality of the sample and how representative it is. So what is a parameter? Parameter is the number computed from population data that characterizes the population. So back to the GPA example, if I want to know something about the GPA of third year students in the FI, and I can't get the information on all of the students, I cannot calculate the parameter of the average GPA. If I calculate a sample, try and make it as representative as possible and calculate the average, that would be a statistic. But the idea of the statistic is to be able to speak about the actual GPA of everyone in third year, alleviating my uncertainty. I don't really know. Here's my sample result. How good is it? That's the business of econometrics or statisticians, right? Trying to find better and better methods to make our estimates, to calculate our estimates and make predictions. All right, so for instance, we use symbols. You've seen these symbols. These are the parameters that are our goal or objective. We want, for instance, to know the average GPA of third year FI students, but we don't have that information. We can collect a sample and calculate the average, and we give it a name. This is a universal symbol that's used all over the world for the sample average, the sample mean. It's X bar. X bar estimates. This symbol is a Greek letter. The Greek letters are reserved for population measures, population parameters. Another parameter that we try to estimate is the standard deviation. I'm going to talk about that in a bit. The standard deviation, the symbol for the population standard deviation is the symbol sigma, which is S in Greek letters, and where this one is mu in Greek letters, which is M for mean, this one is S for standard deviation. This is estimated by the sample standard deviation, or S. Again, these are universal symbols. So, in conclusion, for populations, we have parameters, characteristics of the population. In samples, we compute statistics. So P with P and S and with S, if you ever forget the terminology. And I could have other parameters I could be interested in, right? There's a lot of other parameters. One in particular I'll write down is the population correlation coefficient, and it's estimated by the sample correlation coefficient. And that word sample is often thrown out, but it's assumed that this is the sample mean, even though I won't say sample mean every time. And it's assumed when you see S, it's the sample standard deviation, but I won't say sample standard deviation every time. And the same with correlation coefficient. I'm going to use the symbol. What is the symbol for the correlation coefficient? Who knows? The symbol. No one? The symbol for the correlation coefficient is R. It's pretty universal. If R is the sample correlation coefficient, what is the population correlation coefficient? What's the symbol? It's a Greek letter. The Greek letter R looks like a P, unfortunately, but it's R. This is a row, and you're going to see it, so I'm showing you now. It's the letter R in Greek. Okay, so the Greek letters are reserved for parameters, and we use the alphanumeric or alphabet letters for samples. Okay. So once you get some data from a sample, you want to display it. I didn't give you an example on doing that, but let me think if I should give you an example. The best example I'm going to give you some numbers. Okay, so let's make just so we remember what those drawings are, I'm going to get rid of my red. Use blue. All right, so here's your data. This represents the baseball player Babe Ruth's home run hits per season of his career. Okay, so what do I do with this data? There's 10, right? 1, 2, 3, 4, 5. No, it should be 15. 6, 7, 8, 9, 10, 11, 12, 13, 14. So what do I do with these numbers? I'm missing one. So the first step is to rank them. So you put them in order. Once you put them in order, then you organize them in groups. So you rank them 22, 25, 34, 35, 41, 41, 46, 46, 46, 47, 49, 54, 54, 59, 60. Okay, so you guys don't have to write this down, just watch. So I want to group, so there's my data. Just looking at it, the question is, was Babe Ruth a good baseball player or a good hitter? Looking at the numbers like that, can you make any statements? You have nothing to compare it to. I could give you a comparison set, but I'll tell you that he held the record at 60 home run hits for many years. for like 30 years or something. So these are high numbers. It's nicer if we have a second data set, but I don't want to get into making this too complex. The point is, we want to observe these numbers not just like this. You don't want to give this to someone, right, to make your point. You want to display the data in a way where you group together the numbers that are similar to show a pattern. And we can demonstrate a pattern with what's called a stem and leaf plot. You can make a histogram. Okay, the nice thing about the stem and leaf plot is that we can actually see the numbers. The idea is to separate the data into groups, into classes. So you would put it in between 20, let's say, and 29, 30 and 39, 40 and 49, 50 and 59, and 60 and 69. So this is one way to divide the data up, to look at it, to put together numbers that are similar enough that we could say these values are frequent or not so frequent. That's what we want to try and do. So we group together, we put the first digit here and the second digit here for 22. And then the first digit for 25 is shared here, but I put the second digit here in the leaf area. See, this should look familiar. Then I get the next one is in the 30s. So I put the 3 here, but then the first digit goes there and the second digit goes here. So I have 34 for that, and then 35. The next is in the 40s category, and I have a 1, a 1, a 6, a 6, a 6, a 7, and a 9. So there's lots in this class. There's a lot in this class. We call that the modal class because that has the most observations, right? This is what I want to get out of my pattern. What are the most frequent observations? Which observations occur and how often, and how are they related to each other? So statistics is about averages and relative measures. That's what you find when you take statistics. That's the basis for all of it. So 5. How many 5s do we have? 4, 4, 9. And 6s, we just have 1. There you go. That's my data. And what I do then is I smooth out the data, saying if I had more observations, if I look not just at his hits in the major league games, that I looked at all his hits over all those years and all the games he'd played, even exhibition games and practice games, okay? If I looked at all of those, I had all the data on all his hits, I believe it would still look like this. That's what smoothing out means, that I believe this is the idealized version. So when you smooth, you're imagining that you have all the data, all the population. Maybe mine's a little bit, I can make mine a little bit more peaky. My drawing's not the greatest. There, I want to make it more like that. You get the point, Hope. Okay. So what does this show? So you need to comment then. This is when you look at a distribution. Oh, the neat thing I can do on this iPad is I can take this and I can take it over here and I can do this. And this is usually how you see distributions, right? You turn them on their horizontal and look at them like that. And looking at it like that, we can comment. we first comment on the shape, because the shape determines the statistics that we will compute. Whether or not you remember this, what I'm talking about, this is how it is. This is what you're supposed to do. Always, always, always graph your data before you calculate anything. And I'm telling you, even the doctoral students that I've had don't know this. So you know more than a lot of people if you follow this rule. Always plot your data, because that will determine the statistics that you calculate. If you just go ahead and put numbers into a computer and turn out statistics, you don't know if they are the right ones. Okay, you don't know which ones to pick, because you get a bunch of statistics thrown at you. You're not sure which ones to pick. So just like this looked pretty meaningless, we put them in order. It looks a little bit more meaningful. This is a better summary, but even so, some numbers, some numerical summaries would even be more helpful. So what shape do we have? We have this kind of shape, right? This shape is known as symmetric. This is a symmetric shape. And that's the first step in 5 features we want to comment on when we look at data sets. The thing about the symmetric shape is that there's like a mirror from the center value or the modal class in that group. Whatever I see on this side, I tend to see on this side. So what it means is most of the observations are around the expected value or the mean value. Some of them are higher, but just as many are lower. Some of them are much higher, fewer of them are much higher, and just as few of them are much lower. It just offsets perfectly. And we're going to talk about this in a moment, that actually the mean is the center of gravity, and it's right in the middle for a symmetric distribution. This is often used for measures of height and weight within a large sample. Often it will have this shape. Also grades on tests for large standardized tests will have this shape. So for the SAT, for instance, or like those tests like LSAT and MCAT, they'll have a shape like that. And in terms of the financial markets, it is the case that over time, and we'll look at this in this part of the course, that over time, returns to the stock market. So there's an index that gets calculated, including the top capitalized companies. So the highest valued stock are included in an index, and we get indices like the Dow Jones Industrial Average or the S&P 500, which is with the 500 top companies, Fortune 500 companies. Also create an index, and monitoring that index over time, if you were to make the just like we did, create the distribution of those returns to the stock market using whatever index, it will exhibit this pattern over the last 80 years if you look over time. Regular, predictable pattern. Okay, that's because it's most of the data is around the center. That's different from the other two examples. So if it's not symmetric, the data is going to be right skewed or left skewed. Right skewed means that when you imagine a number line that goes from small to large, there's just a few large numbers set apart from the rest of the data. With a left skewed distribution, there's just a few large numbers, a few numbers that are much smaller than the rest of the data. Now you can see that in data sets for sure that can happen. What you have to be aware of is that your statistics, the statistics that you use will change. Now in finance, we pretty much focus on this because we're looking at stock market data. But if we have smaller data sets or data sets that we don't know about, we should graph them and we should see what kind they are, which kind of pattern they exhibit. So what happens here is when I look at the next step, summarizing the center of the distribution, for symmetric data, the center would be the average. But it turns out that the average or the mean is the same as the median and the same as the mode for a symmetric distribution. What's the mode? The mode is the class with the most observations, and that happens to be the same place where the mean is on the symmetric distribution. But what's the median? That also is the same. Does anybody remember what the median is? What does that mean, the middle value? A little bit more information. Right, so with all the data sorted, it's the middle value. That's right. So that turns out to be A. Wherever A is, that's going to be the median as well. So let's look at if there's just few extremely large values. So income is an example of data that you will usually hear the figures as median income. You don't hear about mean income, okay? When you hear the reports, or when you hear reports, or you hear the news, or you read reports, it's often on the median income. And that is because there are the 1% out there, the few people, right, out of everybody who have a lot of money. And that creates this right skew. So think of that as your example. And that leaves us with the question, well, what is the expected value? In other words, if we were to bet, if we were to think about, you can make it a friendly bet, or you could say if you are, anyway, we'll just leave it at the friendly bet. So if it's a friendly bet and you're sitting outside and you see somebody passing and you're with your friend and you say, well, what do you expect that person's income to be? Okay, so let's say you're sitting at the university and you had some information on income, and what would you expect? What could you expect that income to be? Or if you're looking at a certain career and you were able, you knew that this was the distribution of people income in that career, and you were thinking about it for yourself, what could you expect your income to be? A, B, or C? If you had to pick one number, which one would you pick? A represents the mode, right? It's always where the peak is. What are B and C representing? You guys are telling me A because you're saying that's what you would say what your income would be? Okay, so you think, so that's your mode. What are B and C? What's B? What's C? What are those lines trying to, what is it differentiating? I don't know the exact value, but there's B and then there's C. It turns out that C is the mean, okay? It'll be the mean because where this is the mode or the modal class and this is the median. The median is always the compromise between the mode and the median. It's always in the mode and the mean. It's in the middle of them somehow. The issue is that the mean will be closer, I know, without knowing any numbers, I know the mean will be closer to the tail because the mean uses all the values including the extreme values. Including the extreme values. They have to, right? The mean is all the numbers added together and divide by the total number of them. So it has to use all the values. The median, on the other hand, doesn't. The median is just computed by the middle value. All you have to do is put everything in order and pick the one in the middle. That one you pick doesn't have to do anything with the one that's in the extreme, except that it's smaller, but you don't know the relative measure. You don't know this number, the actual value of it doesn't go into your calculation. Okay, so the problem is, I say problem, but the difference is the mean will use this in its calculation and the median won't. And that will effectively leave it closer to this peak. So when faced with this dilemma of which one to pick in making your prediction, from here on out, you know the answer. I'm going to tell you. When data are skewed, you use the median. There's no good reason to use the mean because it's not the center in any good way, right? There's no real center. Median is a center because it's actually in the middle of the 50% on one side and 50% on the other. The mode, it's showing, the peak of the observations, but there's so much more data over here that you'd be ignoring that if you picked it. So when data are skewed, you always pick the median, all right? And that's why when you hear about income, usually if things are calculated correctly, you're being reported with the median income. All right, let's go to left skewed. So for data that are left skewed, what are A, B, and C? Tell me, what's A, what's B, what's C? Which one is mean, which is median, which is mode? So left skewed data can occur when you have just a few low values and most of them are high. So I use an example, just a general example of school grade completed. Just a few people have no education for a variety of reasons, but just a few of them. Maybe they were held back, maybe they had mental challenges, and otherwise most people have 9, grade 10, grade 11, grade 12, and they're all around here. Okay, so what's A, B, and C? What are A, B, and C? And which one should I use as a measure of center? Very good. Right. She answered everything. Tiana. That's right. So A is the, and it seems easy. Don't forget this stuff. This is, if you finish this degree and don't know this, I'll feel so ashamed of myself. So mean, median, and mode on a left skew distribution are like this. And we choose to report the median because it's not affected by those extreme low values. Okay, now having said all of that, in finance we're going to focus on symmetric distributions usually, but you should plot your data. In fact, whenever somebody reports a mean, they are making the implicit assumption that the data underlying that calculation was from a symmetric distribution. It's very loaded, the mean. It's a very loaded thing. The mean is actually the center of gravity for the distribution. It balances perfectly the weight on this side with the weight on that side. How do I mean weight? There's an area here of this density curve. We call this the density curve. There's an area here, and that's perfectly balanced. So that's balancing off the values and how often it takes those values. And this as well, the values and how often, all the way to this value. That's really important, and it comes up again. We'll see it in a bit. Don't forget that. So it's a physical center of gravity. The median is the, like we said, the value of the observation. So it might not even be an observation. It might be between two observations. We're not going to get into the details too much, but you guys can review that. But it's the middle position between the, over the ranked data. So where 50% of the observations are to the left and 50% are to the right. So that means sometimes it'll actually be the median. Like if you have a sample size, you know, the symbol we use for sample size is n. If the n is odd, then the median will be one of the values. Right, so if the n is odd, the sample size is odd, if the n is even, then you have to take the two middle values and average them. All right, and so in that case, the median won't actually be one of the numbers. It'll be between the numbers. And so when we say 50% of the ordered observations are to the left of this median, when they're odd, you're also including the median when you speak about that. Finally, the mode, the other word for the median is also the 50th percentile. That's another way to speak about it. The mode is the most frequent observation or the most frequent class. It's a good measure of the center when the data are symmetric. I should say data is plural. I just want to make one more point about this. Even though mode, median, and mean are the same, roughly the same, when the data are symmetric, the convention is to report the mean. Okay? But you could just as well give the mode as an answer or the median. However, in statistics and all the fields that use the tool of statistics, they report the mean when the data are symmetric. Okay, it's just it's just the convention. That distinguishes it from the median when it's skewed. So when you see somebody reporting a median and you assume that they know their statistics, they have assumed, or they figured out that the distribution from where the data came was skewed. Some people say asymmetric as well. All right, having said all of that, there's another measure. We're going to talk about this one later. Another measure of center is the geometric mean. The geometric mean that we're going to use is this version down here for rates. So don't worry about it too much, but you'll see this later. What does this look like? If we say I represents, let's say, interest rate, what does this remind you of when you stare at that? I'll leave it with you guys. Well, it'll come up in the next, by next week we'll talk about that. But just think about that. I'm just going to make a note, look familiar. You'll see this again. Okay, it's not important right now, but we'll deal with that later. Okay, so next, oops, I didn't want to do that. Oh, I actually made a stem and leaf for you here. Sorry, hold on a minute. So let me just say, the thing that we would do next, we've got the shape. We've determined the center given the shape, or we know how to do that. The next thing to do in terms of the features of the distribution, the idea is to report with the features the regularities of the distribution and the curiosities. These would create a set of summary statistics for you, and it's advisable for a systematic way to report on a distribution. So, and I don't want to get into all of it really because it's not everything I need. I just want to work, I talked about the shape, I talked about the center, and now I want to talk about the third thing. And I'm going to leave these two out. It's not important for the course, but these are two other things that you should include in any kind of report about a sample. Okay? The third thing, though, is the spread of the distribution. So we were talking about making predictions and what can we expect, and that we would use for the expected value the mean for a symmetric distribution, but the median for a skewed distribution. What if that one value doesn't capture the distribution, however. It just shows you, I mean, it reflects the shape because, like I said, you should only use a mean when it's symmetric and only a median when it's skewed, but it doesn't really show the spread of the values, like how far, like, because if I gave you a mean and I said, oh, well, it's a symmetric distribution, but What if the data was really spread out like that? That's also, let me do this in a comparable way. Right? What if the distribution was really flat like that? You're not, by saying the mean, that doesn't tell anything about this spread, and that's important. Why do I care? What would distinguish this from this one? What would be distinguishing between them? Let's say they had the same mean. And they both represented the returns to an investment opportunity. So they both had the same mean. They both had the same mean. I'm not giving you the numbers, I'm just showing you this pattern. And you are a person who's known as a risk-averse person. Which one would you invest in if you had to pick one? This one or this one? If I call this 1 and this one 2, gee. So if I just told you the mean, I'm not telling you enough. So which one would you invest in, 1 or 2? Come on, somebody. Okay, I'll draw 1 in a way that looks more like this one. This is my redrawing of 1. So this is 1. And it has the same mean. So which one would you invest, 1 or 2? So what you're supposed to think about it, okay, first of all, why am I telling you this now? I'm telling you this now because I'm saying A isn't enough. You need to know the pattern. Here, A is very regular, it's very tight, it's predictable. Not A, sorry, the returns are very tight around A and very predictable to be around A. But in number 2, they're very spread out around A, making them more, what's the key word here that I'm looking for you to say? Anybody know? Yes, these are returns. These are returns to the investment. Some people have said 2. Okay, that's a good word, Juan. The word I'm looking for is riskier. Okay, so 2 is riskier. It's more volatile. More volatile. Now, some people, I mentioned that if you're an investor who's risk averse, you don't like risk and you would go over here. Number 1. But if you like risk, there's a chance you could end up on the high side. But it's just as likely that you're going to end up on the low side. So if you're a risk averse person and you got these 2 to choose from, and A is your average, you pick this one. You pick number 1. So did you guys learn something today? So this is why we need the standard deviation. The average isn't enough. I need to know how risky that A is. How likely that A is. Got it? Tell me you got it. So the average, just knowing the average isn't enough. You need to know the standard deviation for a symmetric distribution. If it's not a distribution that's symmetric, if it's skewed, there's another measure of spread that you would use, and I'm not going to get into it because we won't need it in the course, but it's a 5-number summary and the IQR. You would have to get the interquartile range. So there are different percentiles to look at skewed distributions, but in finance, we just use the standard deviation. All right? So let's do that. Let's remember what the standard deviation is. So what I'm going to make a note here on this. If you want, I can send you the solution for this one. This is for skewed distribution. If you're interested, let me know. I will solve the whole thing for you, so you have it for your record. But that's not what we're focused on in finance, or at least not in this course. Okay? So email me if you want the solution to this marketing consultant problem with 50 consecutive shoppers and how much they spent at the grocery store, how much do shoppers spend, how can the data help the store's marketing strategy. Okay? If you want that, email me and I'll send it to you. Okay, I'll just send it to everybody. But it's not a part of this course. Well, it's part of your knowledge base. You should know it. But I want to focus right now on standard deviation. And again, this is review, so I don't even need to be doing this. But I really think this helps me teach, and helps you follow. Okay. All right. What we're going to do is calculate the standard deviation together, and I will send you the solutions for this. It's actually document 5.2 that's not in your email right now. I wanted to leave it out because I don't want you just to calculate it. I want you to understand. We have like a half an hour. No, we have 20 minutes to solve this together, okay? That you understand once and for all what the standard deviation is. Because statistics is about averages and relative measures, and the standard deviation is an average. It's a type of average. And other statistics you calculate are averages, types of averages. And once you get that, and once you start seeing the patterns, statistics becomes much, much easier to understand. So here are the pocket money data for a student, by a student, that they have for snacks and lunch over the past week. How much money can she expect to have in her pocket in a given week? So we're going to use this as a sample from a population, and when we look at it, there's only 5 data points, so there's only 5 observations. This makes calculations easy for us, given the time constraint. And we just have to realize, if we calculate the average of these, what are we assuming? We're assuming that this is symmetric data. So we have to make that statement until, at least in our head. So we assume data are symmetric. And I'm not going to say this again. It's just an assumption. When I calculate a mean, that's what I'm assuming. So this is the symbol that we talked about for the sample mean, and this is what you see in terms of formula for it. This is the Greek letter, it's another S, it's a capital S in Greek for sum, that you've probably seen that. It's in your Excel spreadsheet software too, you've seen that, sum. And this says, add up all of the observations and divide by how many there are. Whenever you see this symbol with a sigma and an N, you should be thinking the word average. Okay? So this is the symbol for the standard deviation. What do you recognize in this formula? Again, I haven't said the word, but these are sample means and sample standard deviations. You see the average inside of it. Very good. Oh, you see two averages, right? You see this. But also you see an N and you see this. And I told you, whenever you see like an N and a sigma, you should think average. Now it's not exactly like the average over here, because that's just an N and this is N minus 1, but I can explain that. And what is it the average of? It's average of something big. But if I cover that up, like if I cover that, see if I can cover that. You know, if I cover that up, I don't know if that's a great job, but it looks like this one, right? And that, so it's an average. When I put quotes around it, because it's with a little twist. It's a little bit of a twist. So, what is this thing inside? What are we doing? So, we are calculating a measure of spread. Spread, what are we talking about? Spread from where? Well, we're interested in how spread out the values are from the expected value. How spread out are the values from the expected values? Very important to me, because I'm anticipating A, but I might get something else, and it's more likely I'll get something else over here in number 2 than I will with 1. So I want to know how spread out the values are around the average. So what I'm going to calculate is what this is. This is called the deviation from the mean. It's the deviation from the mean, right? It's the value minus the mean. And I'm going to do that for every observation, and then I'm going to explain what the heck this is in a minute. So I'm going to explain all the quirky things, but let's look at the deviations from the mean first, okay? So let's do that. Let's calculate all the deviations from the mean, making a new list of values. Oops, that's not what I wanted to do. So don't do this, don't fill this all in. Let's do this together. Because actually, a professor saw me presenting this once and he thought it was really helpful. So some people don't really they don't get this. They don't get this until someone spells it out for them. And I guess someone spelled it out to me. So now I get to share it with you. So here's a list of observations. And this is going to be my list of deviations from the mean. So let's first get the mean. Oh, I want to show you how to do this in your calculator too. So let's take advantage of that. We're going to calculate both the mean and the standard deviation with our calculators. So you have it once and for all. If you have different calculators, you guys can figure it out, or let me know if you can't figure it out. Often there's YouTube videos on this for different calculators. But let's do this together. So the numbers are 2, 8, 10, 16, and 5. So I need to go to here and clear this, and I'm going to go into stat, second data. Okay, so this is stat mode, right? I'm going to enter the data into here just for X. I don't have a second variable, I just have one. So I'm going to enter 2, enter down. Oh, I need to clear this because there's something in there. Let's clear that. So every time you need to clear a worksheet, you need to open it and then second clear work. All right, so I'm starting from scratch. So 2, enter down, and I'm going to skip that. Now I'm going to put 8, enter down, down, and then 10, enter down, down, and then 16, enter down, down, and 5, enter down, down. So I have all the observations in. I can scroll through them to see them. So 2, 8, 10, 16, and 5. And then I can ask the calculator for second stat. What it's going to give me is the results of a linear regression. But at the same time, it's going to give me the mean and the standard deviation. So it's going to give me that n is 5, x bar, which is the sample mean, is 8.2. In our case, this is $8.20. And let's keep going. It gives me this. What is this? You must have entered something wrong. It should be 8.2. Check, scroll through your results, through your values, 2, 8, 10, 16, and 5. Okay, so then this one, okay, be more specific, Tiana. What is it? So $5.31 is the sample standard deviation, and $8.20 is the sample mean. Does everybody get that? I'll wait for you. Okay, some of you got it. All right, now I'm going to ask you, what is this? But which one, Ariette? So this is the standard deviation of the sample, and this one is what? That's right, you see the Greek letters, so you know that's the population standard deviation. And it's a little bit smaller, isn't it? So, what did we just find out? So we have the results already. I'm going to go through the results and then we're going to go through the table, okay? Because both are important to me. So it's X bar is $8.30. I just wrote it down. $8.20, and S is $5.31. But you also learned about sigma. What's sigma? $4.75. So which of these do we use? This is an example where you get all these statistics and you have to decide which ones you use. Which ones should you use? Nobody? It's buffering. We are buffering. Why did it do that? Did they stop talking? Oh. All right, I have to keep drawing or it buffers. Okay, so you guys don't know? So essentially, you don't use this one because that's the population. You don't have the population, you have a sample, so you use the sample results. The calculator doesn't know if you entered the sample results. Or if you entered the population. Okay, uh-oh. I'm not sure what's happening. Why is this happening? I'm not sure why it's buffering. Can you guys follow? Oh, it's annoying. Why is it saying that? Let me know if you're there. I'm going to refresh. Okay, so we don't use the population parameter because we don't have the population. We use the sample statistics. What is it doing? The calculator is calculating sigma, which would be this. So the calculator is just treating your values as though they are the population values and your sample size as though it's the population size. So this is the parameter and this is the estimate. S means to estimate sigma. So you see, X bar is used instead of mu because you don't have mu. And this is supposed to be a capital X representing, this is a different symbol that's used for all the observations when you don't have all the observations. And capital N is used because it assumes that you have the population size, but we don't have the population. So you see what happens is, because you don't use sigma in here, what happens is the results of your S, your standard deviation calculation, if you used N, wouldn't be very good. In fact, it would be biased. And the point of trying to estimate this, the point of the standard deviation, the reason you want to use it is to represent the spread of the data. You want to be able to capture how the data are spread out. And you're going to miss something if you divide by too large a number. Notice this was much smaller. Well, this was smaller than this, right? Because this would divide by 5 rather than 4 that's used here. So this is known as adjusting for degrees of freedom, which is effectively as a result of the fact that here, even though you had 5 values that are considered random, they're all tied together when they estimated X bar, and you lose a degree of freedom. So rather than dividing by 5 degrees of freedom to get an average, you divide by 1 less. And this is an adjustment that was tested by statisticians and proven to be unbiased in repeated samples. So what they do is they create a population, they sample from it with a computer. They could do it manually, but now you can do it with a computer, and they calculate many different S's. And then, so they would go in and they'd get different samples from their created population, sample 1, 2, 3, 4, and they do it for many samples. All the values would be different numbers, possibly, and they would calculate S every time. And so maybe sometimes they would get close to the actual standard deviation of the population created, or let me say it in the positive. So what would happen is, if you took all of these S's that were calculated from all the possible samples and found an average, it should be the sigma, the actual standard deviation. And so this adjustment makes that possible. Anyway, what it does, so how do we interpret this? How do we interpret these numbers? What do we do with these numbers before I actually go into the calculation? What it means is, on average, she has about $8.20 to spend, right? And then you use this number to say give or take. You use this number to create a range, an interval around $8.20. So we say she spends about $8.20 a day, give or take $5.31. And we say this since the data are roughly symmetric about the mean, and there are 2 rather large numbers balanced by 2 rather small numbers. So I'm trying to validate my assumption that there's symmetry in using the give or take. So what I'm doing is saying $8.20 give or take is plus or minus, I make an interval, $5.31. So if we create that interval as a range like this, what's $8.21 minus $5.31? And what's $8.20 plus $5.31? Oh, we're over time. Okay. Let me finish this and then we'll go, and I'll do the calculation next class. So how many of the observations fall in this interval. Let's go back to the data. Does 2 fall in the interval? No, it doesn't. Does 8 fall in the interval? Oh, I put 531. Sorry, why did I do that? 530, 13, I just recopied. I wrote it. Sorry, let me fix that. $13.51, there you go. So is 8 in that interval? Yes. Is 10 in that interval? Yes. Is 16? No. Is 5? Yes. So what happens is 3 out of 5 of the observations, or 60% of the observations, are in 1 standard deviation of the mean. And that's what we expect. That's how we use the standard deviation. It shows us the spread of the data around the mean, and we can be sure within 1 standard deviation, we get the majority of the data. Okay? So it captures, it's like a net that's cast to show you how spread out the numbers are, and it helps you make decisions. It helps her know she can afford, because given her spending, or given her the pocket money that she had in the past, she can expect to have between $8.20 plus or minus $5.31, so between $3 and about $14. So she's not going to have, most of the time, majority, she's not going to have, $15 in her pocket or $20 in her pocket. She's just going to have 60% of the time between here and here. We could also look at 2 and 3 standard deviations, but we'll pick up here next time, okay, because we're past time and some people have plans to leave. So hold on to these. I'll be in touch tomorrow with the test. Let me know if you have any questions before the test, and we'll pick up here next class. I'll also send the new set of slides for risk and return, which is our new topic. Okay? So have a good night, good studying, have a good sleep, and keep in touch. It's like a cliffhanger, no? Anticipating me solving this problem.